Alright, so in this video today, we're going to talk about studying light. Today you're starting into a unit on astronomy, and one of the important things to study in terms of astronomy is the study of light. There are a lot of distant objects when we deal with astronomy. We're talking about things typically that are far away from us, and so the way in which we study them is to study the light that they emit towards us. So our essential question today is how and what can we learn about distant objects? And that's why we're talking about light, is because light is the way in which we learn about them. So we're going to start out today talking about how we learn about things that are closer to us, and then go into how do we learn about things that are far away from us that we can't touch and feel and those kind of things. So go ahead and write down your topic and your essential question and your Cornell notes, and then we'll get started here. You can pause this presentation anytime if the students need more time to take down notes. Alright, so we're going to continue on here with an introduction. As we go through, you only need to write down things that are underlined. So on this slide, the only things you're going to write down are introduction and water. And the reason we're starting out talking about water is because we know a lot of things about water. We know that it's made of hydrogen and oxygen. We know its boiling point. We know its freezing point. We know a lot of different things about water because water is tangible. Water is something we can observe here on Earth. We can do experiments on it, those kind of things. So we know a lot about water. We know a few more things about water. Here's a few more for you. We know the mass of 1 cubic centimeter is 1 gram. We know that it exists in all 3 states of matter at normal Earth temperatures, solid, liquid, and gas. It exhibits things like surface tension as well as capillary action. And these are things that you may not necessarily know what they are, but that's okay. So these are things that we know about water because we can study it. So how do we know these things? How can we, whoops, sorry, that's a video I'm going to show you in just a second, but we're going to go back to the notes for a moment. So how do we know these things about water? That's the question we need to ask ourselves. And so the reason we know these things about water is because water is here in front of us. It's something that we can do experiments on. It's something we can hold in our hands. We can do things with because it's right here in front of us. And so a process called electrolysis tells us what water is made of and allows us to determine the chemical formula for water, which we know is H2O. And so this is an electrolysis demo. This is what I'm going to show you here. This kind of just shows you what the process of electrolysis is and how it points to the fact that water is made up of hydrogen and oxygen. So I'm going to go ahead and play this for you, and then we'll come back and talk about it.
If we connect an electrolyzer filled with distilled water to a source of direct current, we can observe a slow evolution of gases. After some time, we notice that the volume of the gas released at the cathode is double that of the gas formed at the anode. To identify the gaseous products of the reaction, we collect each gas in a test tube and check its behavior in the presence of a glowing splint. The characteristic cracking sound proves that the gas released at the cathode is hydrogen. The ignition of the glowing splint is evidence that the gas collected from the anode is oxygen, which supports combustion.
Alright, so that gives you a glimpse kind of as to what electrolysis is. So electrolysis is basically the process of running an electric current through water. And so what they were collecting in each of those tubes were the two different gases. So the gases were hydrogen and oxygen, and they proved that they were hydrogen and oxygen by doing the glowing splint thing. And as you saw in the video, they talked about the different characteristics of hydrogen and oxygen in the presence of a flame. So we're going to continue on here. So freezing point, boiling point, these are things we know about water. Capillary action, for those of you who don't know what that is, that's kind of, if you look at the picture on the right there, that's basically the ability of water to climb. So if you put a napkin or a paper towel into a liquid and it kind of moves its way up on its own, that's what we call capillary action. Surface tension is the ability for things like small bugs and a paper clip to sit on the surface of water. That's what we call surface tension on water. And so we know a lot about water because, and these are things I want you to write down today.
Chris Miller, call 1609, please. Chris.
All right, so sorry for that short interruption. So these are things I want you to write down because this is important. This is how we learn about water. So when we can touch it, smell it, taste it, see it, those things allow us to know a lot about something when we can use our senses to observe it. We can experiment on it, we can do different things with it. And so because of that, we know a lot about water. Now there's some other things that we also know quite a bit about. And one of those things is the sun. So the sun, we know a lot about the sun as well. We know it's made mostly of hydrogen and helium. We know it has a surface temperature of 9,932 degrees Fahrenheit, a core temperature of 22 million degrees Fahrenheit. And so even though the sun is not something that's very close to us, we still know a significant amount of information about it. Now the question becomes, how do we learn about objects that are very, very far away from us? So we talked about water as something that's tangible, something that's right here in front of us, and so we can learn about it fairly easily. But objects that are further away from us are much harder to learn about, but we still can learn about them, we just have to learn about them in a different way. So when we talk about space, how we know what we know, we can't easily visit the depths of space, so it's hard for us to do hands-on experiments with objects in space. So rather than doing hands-on experiments, we use information that they're sending us in the form of radiation. And so radiation is something that can travel through space that comes to us, and so that's what we study in order to know about distant objects. So radiation is a form of energy. It can travel through empty space. It travels in the form of waves. And there are a lot of different examples of different types of radiation. Some of these you've heard of, some of these you maybe have not heard of as much. But there are a lot of different examples, and this is what makes up what we call the electromagnetic spectrum, and we'll talk about that in just a moment here. So radiation is energy. It can travel through empty space. It travels in the form of a wave. Radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, those are all examples of radiation. And this radiation is traveling from all objects at all times. So all objects in space are emitting some sort of radiation, and they're emitting that radiation towards us, and we can receive that radiation and learn how to study that radiation to tell us something about the object. So the difference between types of radiation is, it's all about wavelength. So the height of the wave, the peak of the waves, the distance between the two peaks is what we call wavelength. And so the difference between a radio wave and a microwave and an infrared light wave and an ultraviolet light wave is simply the distance between the two peaks in the wave. And so that's really what makes the difference between the two. So these are some examples here. For instance, a radio wave has a much longer wavelength than a gamma ray. Gamma ray is the shortest kind of wave. And so you can see that the distance between the peaks of the waves is distinctly different. And that wavelength, believe it or not, makes those rays, though that type of radiation, very, very different from one another. So then there's this thing called the electromagnetic spectrum that we use to kind of arrange all of the different types of radiation. And so all the way from on the left-hand side to the right-hand side, you have an increase in wavelength. So gamma rays on the far right-hand side, those are going to be your shortest wavelengths, all the way up to radio waves, which are the longest wavelengths. And right in the middle, you'll notice there's something called the visible spectrum. And so the visible spectrum is the area in which we as humans see different colors. And so that's why you see it labeled as the different colors of the rainbow. So you go from the red to the violet on the right-hand side. And so within that area, from about 700 nanometers to about 400 nanometers, that's the area in which we see all the different colors that we see as humans. So we cannot see infrared light, we don't see UV light. Those are beyond our abilities to see. So the visible spectrum is where we see all of the different colors of light. I would like you to draw this in your notes. So if you take a moment right now and maybe pause the video to draw that in your notes, that would be helpful. And then the last slide for today, this is just a way for you to remember the order of the electromagnetic spectrum. You will be expected to remember what the order of the electromagnetic spectrum is, and you'll probably be required to reproduce it on a test. So this is just one of the phrases that you can use to remember it. So Rob's mom is visiting Uncle Xavier's garden. That is the phrase that you can use to remember that. So if you would write that in your notes, I know it's not underlined, but if you would write that down in your notes so that you can refer back to that, that would be helpful. And just so you know, the R stands for radio waves, the M is for microwaves, the I is for infrared, V is for visible, U is for ultraviolet, X is for X-ray, and G stands for gamma rays. Right? So this is just a helpful phrase that if you can remember this, then that will help you on your test when you go to try to remember the order of the electromagnetic spectrum. So those are our notes for today. Hopefully you got those all taken down. If not, you can always go back to this video. I'll try to also post this video on Schoology so that you can visit it there as well and get the notes down. All right. I will see you tomorrow in the day 2 video.